Hello everyone. So let us try to go for the next question, and this question is 1.3, that is part of kinematics, and obviously it is from the book of General Mechanics by Irodov, General Problem in Mechanics by IE Irodov. So it's a wonderful problem. So let's discuss this problem. A car starts moving rectilinearly, first with the acceleration W. So in the Eurodo book, they are using the acceleration W. Okay, W as a symbol of acceleration. The initial velocity is equal to 0, then uniformly and finally deaccelerating at the same rate W. So the magnitude of acceleration as well as deacceleration is same. And the total time of motion is equal to tau. So it is also given the total time of motion. The average velocity during the time is also given, that is some bracket V, so that is a symbol of average, and that is in the form of number, it is given 72 kilometer per hour. So how long does the car move uniformly? So the question is that what will be time such that car is moving uniformly? So let us try to approach this problem. This is a very nice problem, and we can solve it completely. And the if you will see the basic formula we are going to use is that S is equal to ut plus half at square, as well as V is equal to u plus at or u minus at. So these two formula are important. And you know that when you are moving with the constant acceleration, you can directly use this formula. But we can solve this problem without using formula by the graph also. So let us try to go in a both way, and we will discuss each and everything. So let us try to go this particular problem. What is going to happen? So first we are going to plot basically V versus T. So let us try to go and plot V versus T. So when we are going to plot V versus T, so this is my y-axis is velocity and x-axis is time. So this is my uniform acceleration. So obviously the constant slope is there and the velocity is going to increase. And after that it is just going to, with the constant velocity, that is moving uniformly. And then it is just going to deaccelerate. It is just going to deaccelerate. So it is just going to deaccelerate. And the total time from here to here is given tau. So this is very interesting. And what we have to do, and we can just do this picture very carefully. So this is the thing. Okay, you can just assume something like this. So what will happen? So we have to suppose this is your A and this is your B. We have to find the time where car is moving between A to B. Let's say this time is delta tau. Total time is tau. And hence it is accelerating with the same acceleration W and deaccelerating with the same acceleration W. Then we can know that area under this curve and area under this curve is also going to be same. That means area under the curve is nothing but the distance, we all know. And the time it will take from this point to this particular velocity, and we can also calculate this particular value of velocity if we can find this particular time. So what is this time? This time between 0 to A, and you can say this is C, where this is going to stop. So time between 0 to A and time between B to C is exactly same. So what will be time between 0 to A? The time between 0 to A is tau minus delta t by 2. This is the time. And time between B and C is also tau minus delta t by 2. And once we can get this particular time and we know what is acceleration, then we can find what will be velocity also. So the velocity up to this particular time, that time is tau minus delta t by 2, is given as W and tau minus delta t by 2. Wonderful. So this is the velocity, and you can say this velocity is V1, you can just put it here. So now we can use either S is equal to ut plus half at square or some v into delta t, or we can find the area under the curve. We can easily get each and we can get this thing. Now it is given that average velocity is given. So this is known. And what is average velocity? That is delta S upon delta t. And here delta S is given and delta, so we have to calculate delta S indirectly and we have given delta T. So what will be value of delta S? So when we are going to calculate, the delta S is equal to V into delta T. Now, the whole idea is how we are going to calculate delta S as a function of time. So obviously we can use the area under the curve and we can easily find the area under the curve with the geometry, or you can use S is equal to ut plus half at square. Both are same thing. So what we have average velocity v into tau is equal to delta S, and that value is the distance between this triangle, and that will be half into tau minus delta t by 2 into this particular thing, that will be w, that is velocity v1, or this particular distance, that is w tau minus delta t by 2. And second thing is this particular distance, and that is your velocity v1. So v1 is again w tau minus delta t by 2 into delta t, plus again this particular distance, this distance and this distance is again same. So we can have half tau minus delta t by 2 into w tau minus delta t by 2. So just half height into base is the area of triangle, and you can find. And if you will see this thing very carefully, you can write it something like half a t square. This is exactly same thing here also. So we can multiply with 2. So we are just going to multiply with 2, and here we have w, and this will be delta t is also. This time is delta t. So we are just putting, sorry. So this value is there, and I am just writing this one. So this part is this one. So w, and we can get this particular value, that is w tau minus delta t by 2 into delta t. So what will happen? This 2 is cancelled, and now we have to solve this particular equation. So once we can easily solve. This is not a very big deal. So let's try to go to solving this. So what is the final thing? We have v into tau is equal to, we have w tau minus delta t by 2 whole square, plus we have w tau minus delta t by 2 into delta t. So we can take a common, so that value is w, and we can take tau minus delta t by 2, or by 4 we can take common, and inside this bracket we will get tau minus delta t plus 2 into delta t, and this whole thing can be written as w by 4 tau minus delta t, and this will be tau plus delta t. And what will be this value? W by 4 tau square minus delta t square, that is average value of v into tau. So this is your final equation, and you can easily find that delta tau is equal to 4v upon tau, and you can just find this one. So that value is equal to tau root under 1 minus 4v by tau into omega. So I think this will be our answer. You can just correct it. So this will be this will be in this side. So this is something like this actually. So this will be our answer. So we can check it. So we can just see that 4 by omega is there, and delta, that will be minus tau square, tau, that will be the answer. So this is the correct answer. You can easily check. So students, so you have to just do this exercise with yourself. But the most important thing is, when we are going to our main agenda, that either you can use the formula S is equal to ut plus half at square, or you can just go for the graph between v and versus t. And student, in general, whenever the question is given for the average velocity, just plot the graph versus v versus t. If it is possible, you can get all the idea. And the one most important thing is, you have to know that when particle is start from 0 and it is going to accelerate, and then it is going from the some particular velocity, the same velocity, it is just going to be stopped. The time is exactly same. The distance is traveled by the exactly same manner. So this is the main crux. Students, you have to solve this problem with yourself, and then you can see whether it is how you can learn the concept of average speed or average velocity. Thank you.